So we've seen the sum limit law. We've seen that it works when you know that both limits exist. And we've seen at least one sort of schematic graphical example sort of indicating how it goes. So now that we've got the basic idea, I want to tell you the other limit laws and just discuss them briefly. And then we'll do some examples. So the second one, people call this the constant multiple rule. It says, well, just like before, let's say we have some function f of x, and let's say we know that the limit as x goes to a exists. And it could be anything. Oftentimes people just use the letter L for limit, but it could be, who knows what it is, but it exists. And so say that you know that you've got some constant. Could be the number 3, could be the number 4, but whatever, it's just a constant, and oftentimes we use the letter k. And what this says is that if you want to calculate the limit as x goes to a of k times f of x, then this is going to be nothing but, as you might expect, nothing but k times the limit as x goes to a of f of x. And so why is that true intuitively? Multiplication by k, what does it do? If k is negative, well, it flips the function upside down. And if k is 0, it sends the function to 0, and then left-hand side and right-hand side will both be 0. If k is not 0, then what you're doing at that point is basically stretching the y values by an amount equal to the absolute value of k. So this is saying that the limit of the stretched function is equal to the stretching factor times the limit of the function. So intuitively it makes sense. I can show you a formal, what we call a formal proof of that in another video. But for now I'm just stating the laws and we're getting the basic idea. Let's continue. Here's one that's called the product rule. So as you might expect, if you take the limit of a product of two functions, then this is going to be the product of the limits of the two functions. And this one actually is not quite so easy to prove if you are into proving things, and I am. And so when it's not so easy, but once again, we're just writing on the statement now. It certainly makes intuitive sense. The product of two functions, it's similar to multiplication by k, but this time this function gets to vary with x. And as long as both these limits exist, this will always be true, no problem. Other things you can do, it also works with division. So you can say that the limit of a ratio of two functions is going to be the ratio of the limits. And here you can see that I stopped writing f of x and just wrote f and g, and that's sort of like a shorthand notation. It means the same thing. You could have written f of x instead of f. And this is going to work as long as the limit as x goes to a of g is not equal to 0, because if this limit goes to 0, that limit might exist. This limit could be an indeterminate form. We'll talk about that later. This could exist, but it can't be this ratio because we can't divide by 0. So we need this condition to work out. And another thing I'll say about this is this limit law is basically the same as the product one, because f over g is the same thing as multiplying function f by the function 1 over g. And saying that this limit is non-zero is the same thing as saying that function 1 over g has a limit. So these two laws are really the same if you think about it. And finally, here's another one, which says if you take a function and raise it to the nth power, n could be a natural number, 1, 2, 3, 4, whatever. Take that function, exponentiate it or raise it to the nth power, then take the limit as x goes to a, and what you can do to calculate that is take the limit of f of x and then raise that limit to the nth power. And this one turns out to be also the same thing as the multiplication rule, because, for instance, you could say if n is equal to 2, if you're looking at the limit of f of x squared, then you could take f of x times f of x. You could take g of x equals f of x in this equation, and it's equal to limit of f of x squared. And then you can continue that process for n equals 3, 4, 5, 6, whatever. But this also works for negative exponents too, even if it was n equals -1, -2, -3. And in order to get that to work, you can see it's the same as this one. So really what you need to remember are the first limit law, the second one, the constant multiple, and this product one. And then you can use these whenever you like, but you'll know that they're the same as just multiplication of two functions. But we like to write them out just so we're completely crystal clear. So those are the limit laws.